Very much. First of all, good morning for everybody in California and good evening for folks from Europe. And thank you very much for this opportunity to speak about graded logic for decision support systems. The basic thing is that this lecture celebrates the 50th anniversary of graded logic. And this is a kind of birthday party. And for each birthday party, you have birthday presents. So graded logic was born in Belgrade in 1973. And birthday presents are, I brought this book, Graded Logic, as a present. And then my friend co-pilot made this beautiful cake. You see, happy birthday cake. And then this little 2-year-old aspiring poet, ChatGPT, submitted this little poem, The Journey of Graded Logic. It says, 50 years ago, a caterpillar small, graded logic inched and crawled. In tender growth it dreamed its flight through branches dense and skies of night. Today it spreads wings, bold and bright, a butterfly of graceful might. In this book we celebrate the way that graded logic flies today. Well, it is not bad for a 2-year-old, okay? So most likely we'll try to write something more in the future. So now seriously, outline of this presentation is I'm going to speak a little bit about human common sense logic and decision making, about graded logic and why we need it, about LSP method that is based on graded logic, and then we make 2 examples, one toy example, job selection, and one serious one, liver transplantation priority score determining. So this is my plan. And the first thing, let us say a few words about human-centric approach to logic. The basic idea is that logic reasoning is a human mental activity. That means there is no logic reasoning without explicit presence of a human thinker. So it is the most natural to use human-centric approach to logic. And of course, here, this stakeholder decision maker who is in the epicenter of our interest can be either an individual or a human organization of any kind. One thing that is very important to realize is that human common sense logic reasoning is observable, measurable, modelable, and explainable. So the goal of graded logic is to develop models of observable properties of human logic reasoning. So you can always see people how they make decisions. You can create experiments to measure that. When you have experiments with recorded measurements, you can make mathematical models. And when you have mathematical models and use them, you can also explain the reason for results that you get. So it is observable, measurable, modelable, and explainable. Logic, of course, is an old science, and there are 24 centuries of logic, moving from binary to graded, starting with Aristotle, and then in 1847, Augustus de Morgan, in 54, George Boole, and then Jan Vukasiewicz is the first in 1920s who suggested that the number of degrees of truth should not be 2, just black and white, but there should be more, 3, and then came N, and then in 1965, Lotfizade presented fuzzy sets, and the number of degrees of truth are now an infinite value, and this is graded logic, which we present here. So there is a paradigm shift. There are 2 approaches to logic. Mathematical logic is an axiomatic deductive theory where all variables are anonymous real numbers. I want to say that not as a compliment. In the case of decision engineering logic, we have that we are working with variables that have noun semantic identity. They are Practical is something that is defined by decision engineer for that stakeholder that we model. Therefore, what we have as a generalization here is that moving from Boolean logic to graded logic, we are moving from vertices of unit hypercube. So if you have unit hypercube, all Boolean and other binary logics are defined in these vertices. In the case of graded logic, logic is defined inside the whole unit hypercube in each and every point. In vertices, of course, we are exactly the same as Boolean binary logic, but inside we have expansion and generalization. So the manifesto of graded logic is that this is key component of human common sense reasoning. Common sense reasoning is reasoning that we see every day in human behavior and logic reasoning. So in my opinion, logic should be based on observable and measurable properties of human logic reasoning. So that's the basic idea. And these are goals of graded logic. So let me offer you a few introductory examples of human graded percepts. That's the first thing. So fundamental concept of graded percept is that percept is defined as quantifiable mental result. So it is an impression or sensation of perceiving or reasoning. And it is always graded in the interval from minimum value, denoted as 0, to maximum value, denoted usually as 1. It is very important that in logic, we have 4 fundamental observable percepts: truth, importance, simultaneity, and substitutability. So what we have and what we propose to have in logic is that in human mind, you have degree of importance for everything that we are using in decision making. There is degree of truth that can go from minimum to maximum value. In the case of simultaneity, there is degree of simultaneity that is adjusted and degree of substitutability that is also adjustable. So we have this coordinate system where we have that we can adjust all these percepts. Let me show you an example. Look at this window. Window is open, okay, but not completely. So if I have statement, the window is closed, what is the degree of truth of that statement? It is 80%. It is almost closed, but not completely. So degree of truth, window is closed, is not 1. If I say the window is open, degree of truth is now 20%, 0.2. If I say the window is 20% open, if this is true, or 21, then degree of truth can be 1. So degree of truth is adjustable between 0 and 1. Graded importance is also adjustable. We have relative importance that, for example, in the case of a senior citizen who lives in the vicinity of park or restaurant or public library, will have the first thing first approach, where importance of vicinity to park will be maybe the highest, 60%, because the senior citizen likes to go to park frequently. Will visit restaurants maybe less frequently, and importance of proximity to restaurants will be 30%. Public library will be visited once per month, so importance of being in proximity of public library will be less than the previous one. So this will be maybe 60%, this might be 30%, this can be 10%. So in human reasoning, there is the basic thing called first things first. So there is no restriction of commutativity in graded logic and in human reasoning. Commutativity is the favorite mathematical property that is at the beginning of all axiomatic deductive theories. And this is a restriction, a terrible restriction that is eliminating all humans. And when you see commutativity, you have to cross immediately the presence of humans. Humans are not modeled in that way. Graded simultaneity. For example, if you are buying a home, you want good quality of home and good location of home. These two things should be satisfied as much as possible at the same time. For any product that we buy, we want good quality and good price. So this is again conjunction and simultaneity. Each component, of course, has specific relative importance. In the case of substitutability, for example, if you have car parking quality, you can have either a home garage or a street parking. And you can combine both things, but they can substitute each other. Unfortunately, in the case of patients, if you have high level of motor symptoms, immobility, or high level of sensory symptom, pain, you have that the patient is disabled. So disability in medicine is, for example, for some diseases, immobility or pain. So going back to intensity of graded percept, for degree of importance, humans will can be lowest, low, medium, high, highest. For degree of truth, can be unacceptable or very poor or average, above average, good, very good, excellent. And for simultaneity, you can say must have all. This is the highest degree of conjunction, must have everything perfectly satisfied. Or to say, well, it is nice to have most, but not that strong simultaneity, or nice to have. And for substitutability, you can say enough to have some things that are satisfied, or enough to have anything that is satisfied, which is the highest degree of substitutability. So we have that humans are manipulating these percepts and giving linguistic label to them and communicating this to each other using verbal approach. Examples of graded percepts are plenty of them. Suitability, preference, confidence, quality, value, pain, weight, aptness, reliability, is something heavy, light, dark, etc. All this is graded percept. All of them belong to 0, 1. Let's say a few words about human common sense decision making. How we make decisions? Well, we usually start by specifying goals and requirements, and then identify goal attainment alternatives. How many alternatives we have? For example, if we seek a job, we can get 3 job offers that we have to evaluate as 3 alternatives, and then find the most suitable alternative. What is the best one? And then ask, is this suitable alternative acceptable? It can be maybe not acceptable. So if it is above acceptability threshold, then we are going to accept it. And then we can decide to select and realize the selected alternative. If we look in more detail, what we do when intuitively making common sense decisions, we have M alternatives. So this is alternative number 1, 2, 3. We can have only one alternative very frequently. And we want to see how good is that alternative. But usually we have more than that. So let us suppose that these are M job offers. And for each of them, we define suitability attributes. For example, if you buy a car, you say, what is the power of engine? What is the number of seats? What is the volume of trunk, etc. In the case of job selection, you say, what is the salary? What is attractiveness of job? What is the time we spent at work per week, etc. For each and every of them, we perform individual evaluation of that attribute. So this is attribute criterion. And this criterion generates suitability degree. That is logic variable between 0 and 1. For n such attributes, we have n such degrees of truth. And now is the big moment for graded logic. We have to aggregate all these degrees of truth to get the overall suitability, which is degree of truth of the statement that the evaluated alternative fully satisfies all our requirements, which is, of course, not always satisfied, or it is satisfied partially. So the logic scoring of preference that is going to be used today will strictly follow this pattern of common sense decision making. So looking at human mind, we have some suitability attributes, and then there is some model in human mind that we use to create output overall percept of suitability. What is inside? Inside is logic aggregation, because some of these inputs are good or excellent or poor or average, whatever, and then we have some logic aggregation using some graded logic function that create the output that the overall suitability is very good or something else. So this is the output graded percepts, and we have input graded percepts, and human mind is performing logic aggregation. That means it has a graded propositional calculus inside that is used to compute this output from these inputs. Well, this is what we would like to do with AI agents and with tools that are helping in decision making. So this is based on graded logic, and this is why we need graded logic. So continuous valued propositional logic. What should be properties of such logic? First, the logic must be fully continuum valued. Everything is a matter of degree. Natura non facit saltum in Latin. So it is practically the continuity of all graded percepts that we have in human mind. First of all, continuum valued logic variables, simultaneity, substitutability, and importance of logic variable, importance which does not exist in traditional formal logic. Intensity of simultaneity and substitutability is adjustable. So we have degree of conjunction that is called n-ness, and it is denoted as alpha. So it is indicator of the strength of simultaneity. High n-ness. What is the high n-ness? That means that we intend to strongly penalize cases where requirements are not simultaneously highly satisfied. So pure conjunction, which is the minimum function, will have n-ness 1, and complementary to n-ness is or-ness, or disjunction degree. Disjunction degree is an indicator of the strength of substitutability. That means how strong we want to reward those cases where there is at least one or two requirements that are highly satisfied. So in the case of pure disjunction, omega, which is or-ness, will be 1. So r-ness and or-ness, what is important in graded logics, are complementary, which means that we have conjunction, disjunction, dualized, and complementary unified approach. That means I am proposing a single function that is called graded conjunction disjunction that is model of both substitutability and simultaneity. And in our mind, we are moving this border left-right to adjust what kind of logic properties we want to achieve. So this is going from drastic conjunction, that is ultimate conjunction, to drastic disjunction, which is ultimate disjunction. And there is continuous transition along various levels of conjunctive and disjunctive properties. Of course, sometimes we need more simultaneity, sometimes less frequently we need more substitutability, and sometimes we have logic neutrality right in the middle. So the function that we use is graded conjunction disjunction called GCD. GCD has an array, a vector of suitability degrees. These are degrees of truth, vector of weights, importance, and adjustable n-ness that can go from minimum to maximum value. So what are properties? Continuum valued in the range of 0, 1. It has the status of aggregator. That means it satisfies non-decreasing monotonicity and boundary conditions in 0 and 1 extreme points. It is n-ness directed. It has non-increasing monotonicity in endness and completely continuous transition from end to or. It is importance weighted. We want non-commutativity to be close to human way of thinking, not to formal deductive theories, which are of course legitimate in mathematics, but not legitimate if you want to model human reasoning. It is idempotent selectable, either idempotent or non-idempotent, which is something that we select. It is annihilator selectable. Do you want or not to support annihilators? And it is dualized and complementary unified. And this is unique, distinctive property of graded logic. So if we take all these properties, graded logic is a seamless generalization of traditional Boolean logic and fuzzy logic propositional calculus, which is based on what we call hyperconjunction or T-norms and conorms. So it is also generalization of non-classical continuum valued propositional logics. The fundamental thing is the graded logic conjecture. What we claim is that there are in human mind and in human reasoning 10 necessary and sufficient graded logic functions. These are graded hyperconjunction, pure conjunction, minimum function, hard graded conjunction, one that supports annihilator 0, soft graded conjunction, one that is not supporting annihilator, we don't need it. Logic neutrality, which is right in the middle as a centroid of all logic functions. This is the arithmetic mean. Soft graded disjunction, hard graded disjunction, pure disjunction, which is maximum function, and graded hyper disjunction. We also need negation. These are 10 functions that exist in human mind that are something that is necessary and it is sufficient. There is, of course, not a formal proof for that, but there is plenty of good reason that support this conjecture that human mind works with these 10 fundamental functions. They are always, it is important to say that they are dualized and they're having adjustable levels. So going from lowest, low, medium, high, highest. So if you have more simultaneity, you have less substitutability and vice versa. So graded conjunction disjunction is a function that has plenty of degrees. And in practice, we use this scale of operators that we use for aggregation. It is practical, medium accuracy. It has 15 degrees of idempotent aggregators and hyperconjunction that includes T-norms, conorms, and hyper is hyperdisjunction conorms, of course. And for example, this is drastic conjunction and drastic disjunction. Drastic conjunction is conjunction when we accept only those candidates that are perfect in each and every component, which is practically the floor function of this product. Z is 1 if and only if X is 1 and Y is 1. If X is a little bit missing, it is immediately 0. Drastic disjunction is, of course, the Morgan dual of this drastic conjunction here. And in between, we have continuous transition. There is verbalized interpretation of these aggregators. So you can say must have all inputs satisfied, or nice to have most inputs satisfied, or to say nice to have input satisfied, which is neutral, somewhere in the middle. Or you can say nice to have some input satisfied. Of course, not all, but some of them would be sufficient if they are satisfied. Enough to have any input satisfied. Now, when we speak about this central point, which is neutrality, I would like to remind you of an example, and this is the average grade of students in each school. In each school, we use logic neutrality to compute the GPA of students because we have simultaneous consideration of two different requirements. The first one is we want students that have A grade in each and every course, but at the same time, we permit, which is fully conjunctive requirement, at the same time, we permit that good grade in any course can compensate bad grade in any other course, which is substitutability or disjunction. So at the same time, we have 50% of conjunction and 50% of disjunction that are mixed together. And this is the logic neutrality. In the case of substitutability, we have must have all or nice to have all, and must have all is mandatory requirement. It is hard aggregator, that means supports annihilator. And we have soft aggregators that are not supporting annihilator. We need them very frequently, of course. And then similar situation is with disjunction. If we have enough to have any, that is sufficient type of requirement. It is again hard. And if you have that one of them is satisfied, it is again annihilator for this kind of logic structure. For example, if you have a home garage that fully satisfies your requirement, you don't need street parking. So that is enough to have. There are also two more complex operators that we very frequently use. This is asymmetric conjunction or conjunctive partial absorption. So we have two inputs, primary input, which is mandatory, and secondary that is optional. We frequently combine mandatory and optional components. So mandatory input must be satisfied. If it is not satisfied, we reject this kind of alternative. Optional input is desirable, but not mandatory. So frequently we have decision situation where we have several mandatory requirements and a few optional ones. And this is combined together. Of course, if we have mandatory requirements, this is must-have requirement. Optional is nice to have. So in the case of mandatory input, we have that if mandatory input is satisfied to some extent and optional is not satisfied, then the result will be, output value will be penalized. So it will be the value of mandatory minus penalty. And if it is perfectly satisfied optional, then it is going to be mandatory plus some reward. So to define this aggregator, we are going to select what is desirable penalty and what is desirable reward, and then we'll compute the operator in that way. Of course, similar thing is partial absorption, which is disjunctive. So it has primary operator that is sufficient and secondary that is optional. So sufficient is one that can completely satisfy the criteria, and optional is desirable but not sufficient. Again, we are going to have penalty and reward. So this is logic that we use to create the LSP decision method. It is called logic scoring of preference, or LSP. Decision method has these 5 components, 5 steps. So the first is to identify the stakeholder and goals, because we said that in the case of logic and decision making, it is always decision making according to needs, goals, and requirements of specific stakeholder decision maker. So this stakeholder has alternatives, A1, A2, A3, etc. So what to do, where to go, that is what has to be decided. We need to know what are goals and requirements of stakeholder. When we have that, then the second thing is to make the attribute tree, to systematically derive all attributes that we need for evaluation and decision making about alternatives that exist. For each attribute, we are going to create attribute criterion, and then for each attribute criterion, we are going to have an input that has to now be logically aggregated to create the overall suitability. And that is where graded logic is part of this picture. We have to have logic functions that are going to be used to aggregate all these suitability degrees for individual attributes. So we have m individual attributes, we have their suitability degrees, and we have aggregation of that. Of course, there is also the situation where many of objects have also cost. So there is going to be cost preference analysis, and therefore we compare overall suitability and value, and finally make decision in this last case. All that is consistent with standard observable model of human reasoning, which has here attributes and attributes. It has n attribute criteria, first, second, and these are functions that are mapping the suitability attribute value to suitability degree, which is a logic variable between 0 and 1. This is interpreted verbally as degree of truth of the statement that the input attribute fully satisfies all stakeholders' requirements. After we have that, we have n degrees of suitability or degrees of truth that have to be aggregated using logic aggregation. And this L is the function of n variables. You can ask me, what is n? Well, in toy problems, n can be 5, 6, 7. In regular problems that have humans in selecting jobs, cars, homes, and similar, this is around 30, 40. In professional problems of evaluation, for example, of computer systems, n is from 80 to 120. The largest models that we had for operating system, n was 600. So we are speaking about professional problems where we have large n. But we are going to start by showing a toy problem to make things understandable. So it is important that always in all these kinds of aggregation, we have possibility to verbalize that. So must have all input satisfied, or nice to have most input satisfied, or nice to have some input satisfied, or any input satisfied, or combining something that is mandatory and optional, or combining something that is sufficient and optional. So all this is verbalized, and this is the way how we select among these 7 fundamental types of aggregation operators. So logic aggregators that are hard graded conjunction, we usually have 3 levels over there, 3 intensities, denoted as hard conjunction, or strong or weak hard conjunction. The same is with soft graded conjunction, and then neutrality or arithmetic mean is here, and then we have disjunction in the same way. And conjunctive and disjunctive partial absorption, these are asymmetric conjunction and disjunction operators. Now, this can be, of course, quantified using degrees of n-ness. So for all of them, we have specific n-ness, and this n-ness is adjustable from 0 to 1. And in the case of hyperconjunction and hyperdisjunction, we go outside of that range as well. So after we know all theory, let us show 2 examples. One is job selection example, the first one, which is a kind of tiny little problem. And as you see, I'm not able to show you how to do things. I am focused on making clear what can be done and why we do that. So in this case, we use LSP method. We define the stakeholder and his goals, his or her goals, define suitability attributes, criteria for each of them, develop graded logic aggregation structure, and compute overall suitability degree and select the best alternative. So first, who is a stakeholder? In this example, this is an individual who currently works from home. The job is very attractive, but the salary is very low. So the primary motivation for a job change is to increase monetary compensations. How to define attributes. Systematically, we say, I'm going to evaluate this job by evaluating monetary compensation and main characteristics of the job. These two things I want to have satisfied, both of them. So what is monetary compensation? Well, this is offered starting salary and benefits that you have. And also, I want to take into account anticipated future salary. So what I can expect in 3 years or 5 years. So this is monetary compensation in this little example. In the case of characteristics of job, we are going to somehow evaluate attractiveness of job. Do we like it or dislike it? And we are also going to evaluate as mandatory requirement what is the total time that I spent at work, what is average work week, and what is daily commute time. These are both things that we have to take into account. So if you ask me, is salary mandatory requirement? Yes, it is. It must be satisfied. I am not going to accept zero satisfaction here. Anticipate future salary is a tricky thing. It is something that can be changed and modified. Therefore, this is not going to be mandatory. It is going to be optional. Okay. Is average work week going to be mandatory? Of course it will, because it is necessary that we work as much as we can afford in specific situations. So here are attribute criteria for these 6 inputs. We have the offered salary, benefits, anticipated future salary, attractiveness of job, average work week, daily commute time. So how to evaluate all of them? Each of them is separately evaluated. If you ask me about average work week, I'm going to say that if average work week is 40 hours or less, this is perfect. I am perfectly satisfied with that. But if I have to work five days, 10 hours per day, maybe I'm going to be satisfied 80% if the salary is huge and if the situation is such that I have other reasons like very attractive job, etc. If I am in startup mode, 72 hours, 6 days, 12 hours per day, this is going to be not acceptable for people in my age. Okay, but you younger folks can make different criterion. This is the criterion that we are going to use for this specific stakeholder. So what we have now is these 6 attributes, 6 attribute criteria, and this is logic aggregation structure. This here is a partial conjunction, the partial absorption function, where offer starting salary is mandatory and benefits are optional. Penalty and reward are decided to be 35 and 15%, which should reflect the needs of specific stakeholder. In this case, we have the situation where we also have another conjunctive partial absorption. And here we have hard conjunction. So these are mandatory requirements, but not very strong. And this one has medium strength. And this is giving me overall satisfaction. So this is verbalized logic aggregation in attributes and parameters of graded logic. You also see here that monetary compensation has higher weight than the job characteristics. So they are close to each other, but we consider that monetary compensation in this case is more important. So 55% versus 45%, these are weights that we have in this case. Evaluations is performed using a software tool called LSPNT, and we have that this is the overall job criterion that can be written in this way. And then you have characteristics in the case of old job, existing job, we have that the salary is considered 100%. That is the non-satisfactory current value. If I get 30% increase in salary, that is going to be better. And here is 10% of salary increase. So this is the job offer, new job 2, and new job 1. Okay, and this is existing old job. And then, for example, since existing job is working at home, it is daily compute time 0. And here we have 2 times 15 minutes. Not too bad. That's rather good, 30 minutes of computing time. And this job number 1 is also offered from home. And so we have these different situations which give us the overall suitability that looks numerically like this. So all jobs has 67% satisfaction, and the new job has 78. So selecting the best alternative has the following option: to accept new job, and you say, I'm going to go from degree of truth 67% to degree of truth 78%, that I am perfectly satisfied. Or I can negotiate salary with new job 1 and then select best offer, or can say 78 is not enough and wait for a better offer. So these are possible alternatives. Now let us make a few say a few words about a serious problem, which is organ transplantation priority criteria for the case of liver. So liver transplantation priority evaluation, what we want to do is to compute for each and every patient transplantation priority score. Who is the stakeholder here? Government, because all governments are defining this kind of criteria. They have organ procurement, distribution, and allocation organization. Domain expert that must be included is medical doctor, and of course decision engineer who is going to make the criterion function. So here is the problem. You have one donor and one liver that occurred overnight in a traffic accident, for example. So you have one donor and one liver, and huge number of people who are waiting for liver. So who will get the liver? You have the problem of deciding who will get this liver, and you have to decide quickly and in the way that saves most lives. So this is a very important problem, and we solve this problem not only for liver, but also we are interested in kidneys and in priority of vaccination and many other medical decision problems of this kind. Of course, it is very good to use LSP method because it is going to give us the transplantation priority score. And in the case of governmental organizations, for example, in the United States, you have that as a part of US Department of Health and Human Services, and there is liver and intestinal organ transplantation committee. What is done in United States, they take into account eight inputs, no more than 8, and they use adding of points, additive scoring, which is from decision point of decision engineering fully unacceptable. Is there something better? Yes, there is. And here is what we suggest: to have priority factors that are not only medical priority factors, which are medical urgency for organ transplantation, medical prerequisites, expected recovery time after organ transplantation, and medical benefits for organ transplantation. So when I start making the criterion, I have to also suggest social and ethical priority factors that are not used in the United States at this moment. So priority factors based on recipient's contribution to society, based on expect social benefits for recipient and his or her family, and priority factors that support ethical aspects of organ transplantation. If we want to develop medical attribute 3, then we have to take things like disease severity, which is explained using MELT score, waiting time for organ transplantation, various forms of compatibility between donor and recipient, like blood compatibility, age compatibility, organ size compatibility. Very important thing, organ delivery time. because organs have viability that is usually up to 1 day or day and a half, or for kidneys more, but it is always necessary to have fast surgery. So there are also social and ethical factors, priority factors that reflect expected social benefits for recipient, priority factor based or residential environment, priority factors based on reducing health inequalities, etc. At the end, recipient responsible adherence to medical recommendations. Some people will ruin liver by drinking, and then after they get new liver, they will start drink again. Well, this is not something that should be encouraged, okay, obviously. So liver attributes are these 14, including this organ delivery time, and social are these 21. So I have 35 attributes that are proposed to be taken into account in this decision problem that can be solved using graded logic. So total is 35 inputs. Now we have to make the function of these 35 inputs. For each attribute, we have to define a criterion. For example, for MELD score, if you have MELD score that is 40, that means that you have practically a predictor of 3-month mortality risk for patients without access to liver transplant. So if this value is 40, is obtained from blood analysis, you are 100% sure that in 3 months you have good chance to be dead. And therefore, this gives high priority. You have to either act or you are going to lose such a patient. How to make criteria? Well, we have to make careful analysis for each and every of these 35 inputs. And here are such 35 criteria. We have to make here a detailed, professional, graded logic structure that is aggregating these degrees of truth in a way that creates the overall suitability. So we have suitability aggregator structure for medical factors and suitability aggregator structure for social and ethical factors. So to make an example, we have here one typical patient that has 70% contribution of social and ethical factors. So we are going to make analysis of this patient, and then we are also going to compare the situation where social and ethical factors are contributing nothing or contributing 100%, or they are unknown. LSP method has the possibility to have missing input data and still working efficiently. So there is also possibility to have somebody who has organ delivery time that is not 10% of viability time, but 50%. So it is worse situation. The overall results are going to be, of course, that this guy who has the contribution from social and ethical factors will be first, and then this who has the 50% of slow delivery time will be 73% only. So we are not going to have a high priority score for it. And the summary is that medical factors are giving to this patient the priority score of 83%. And then if you have the zero social and ethical factor, this is going to reduce from 83 to 66. If you have that medical factors are amplified by social and ethical factors that are not mandatory, are desired, that means they are optional, you get 3% more. So if you look at sensitivity curves, you see that as the disease severity increases, the priority factor is increasing as well. In the case of delivery time, you have this kind of function. As the delivery time approaches 100% of organ viability time, the overall score is going to go down. We cannot give liver to somebody who is very, very far and cannot be reached on time to make the surgery that is necessary. So the priority will be to those patients that are located closer to the liver that is delivered. This is sensitivity curve in the case of social and ethical factors. As you see, they are not going to zero, so it is not neither necessary nor sufficient. It is practically optional. So it is either a little bit decreasing or a little bit increasing above the medical factors suitability that was around 80-something%. So the summary is that in addition to medical factors, we would like to take into account social and ethical factors, and that is the proposal for various governments who are deciding what has to be taken into account and how to improve this system with the goal to save more lives. For each scientific discipline, there is always a road ahead. So here is what Alan Turing is thinking about that. He said, we can only see a short distance ahead, but we can see plenty there that needs to be done. This is the case with graded logic as well. So graded logic is bordering with many other scientific areas, with mathematics and data science, with not classical and fuzzy logics, with various applications, particularly in medicine, agriculture, etc., with theory of aggregation function, with artificial and computational intelligence, with decision analysis and operation research and business decision making, with classical utility theory, behavioral economics, mathematical and cognitive psychology. Very important that there is next to nothing that was done here. So whoever wants to work next, here is plenty of areas where we can penetrate. So for those who want to do future research, there is plenty of possibilities to move forward. If you need more detail and want to see the mathematical infrastructure of this methodology, there is self-computing evaluation logic book and graded logic book that is currently in print by Springer. And that's it. Thank you very much. If you have some difficult question, don't ask me. If you have some easy, go ahead right now. You can unmute your microphones and ask questions. I'll try to answer. Thank you very much for those who stay till the end.
Thank you, Professor. So any questions?
Yes, how can we get access to the recorded video?
I will put it hopefully today to YouTube. There,
Okay.
if you search for ETF BAFA, there is only one channel, and then it will be there.
Got it. Thank you so much for your help.
Any other questions? I mean, I have a couple questions. You know, I can maybe start in the question. So, Professor, can you comment a little bit about how the logic aggregation is being calculated, and can it be probabilistic or it's actually deterministic always?
Can you refine a little bit your question?
I mean, so in some of the logic aggregation, kind of when you do the grading logic, right? Usually you have some kind of percentage there. So like, can it be does it have to be deterministic, or that function there can sometimes give you 20%, sometimes 25%? So you can put like a probabilistic function there.
That is a very good question, and it relates to the way how we select the attributes and how we evaluate them. I said nothing about that, but different types of attribute criteria. So this criteria, there are plenty of different types of criteria. Some of them are absolute, relative, some of them are taking probabilistic things into account. So this is absolutely necessary to take into account everything that is needed. For example, you cannot make donor-recipient compatibility if you don't have that geometrically you have the same kind of size of liver and the recipient. So you cannot put huge liver in a child or small liver in a very big person. So it is good to have various compatibilities. On the other hand, things like MELD score are practically probabilistic things, not deterministic. It is a predictor of the 3-month mortality. But it is mortality risk. That means that is high probability that the patient will not be able to live more than 3 months, but it is not deterministic. So there are also possibilities to work here with things that are probabilities and risks. Another thing is that when we have cost analysis, for example, for various complex financial problems that we have when we build infrastructure. If you want to build, for example, a power plant, then maybe you are going to buy some equipment on credit. And therefore, the question is how to compute the present value of cash flow. And this is also based on probabilistic reasoning. That means, do you have risk aversion, or you are accepting risks for payments that you have to make in the future? Okay, so this is particularly important for governments that are practically borrowing money that cannot return later. So when they make decisions, they should have all these probabilistic things. So indeed, there are many things that are not deterministic in their nature. And these criteria, these attributes should be included, and such criteria should be developed. And this is not difficult. It is all that can be done. Yes.
Hopefully I motivated other people to ask questions. So any questions?
Okay. So what is the next step? A good lunch or a good dinner for people in Europe. So thank you very much.
Thank you so much. And like maybe Graded Logic can help us decide what to do next.
Okay.
Yes, there are many degrees of truth to our answer.
So go ahead to good lunch or good dinner. That's it. Thank you.
Okay, thank you so much.
Why not both?
Wait, Zorane, 1 second. We said that we will just remind everyone that we will have a good lunch for those in the Bay Area on April 27th when we will hold our ETF BAFA picnic. Can you hear me, guys?
Yes, we can. Yes, so
Yeah,
thank
so
you for reminding. So
yeah.
you just put the date, so the usual place, the Hatter Park, on Sunday, April 27th. So we'll make cevapcici as always. So everyone is welcome to join.
Yeah.
And
The same channel where there will be the YouTube announced with the recording. You can also find information about the lunch you will have in about a month if you can join us.
Thank you. So one last question, if anyone has any questions, so I can stop recording otherwise.
I just had a comment. I enjoyed this presentation really. The fact that I don't have specific questions only means that I would like to know more, and really is interesting. And I thank you, Jozo, for presenting, and thank you, Zoran, for organizing this. It was a treat for me, and I had this planned to watch for a long time.
Thank you, Pet.
At the beginning, we had also my email. So for questions, if you have them, I will be glad to answer later using email. So jozo@sfsu.edu is the way how you can reach me easily and continue discussion.
Thank you, Professor, for this great
It was
session.
great, yeah.
And when is the book coming out?
Pardon me?
When is the book coming out?
This is a question for Springer. The new book is being produced in India, this one here, Graded Logic. Okay, and it is going to be in June.